Alright, this will be my video about systems, word problems specifically as a type of system, and I'll also show you how to use substitution as a way to solve the word problems. So let's get right into it. I found this online. This is just a basic word problem that you might see on a test or a quiz, and it says that you're running a concession stand at a football game, and you've got hot dogs and sodas that you're selling, and each hot dog costs $1.50, and each soda costs 50 cents. At the end of the night, you made a total of $78.50. You sold a total of 87 hot dogs and sodas combined. Now it wants you to find the number of hot dogs and sodas that you sold. So, since that's what you're finding, your first step is to identify your variables, and I'm going to do that off to the side over here. We've got X and Y, and it doesn't necessarily have to be X and Y. That's just what I like to use because they're most simple. But I'm going to say that X is the same as the number of hot dogs sold. So you need to remember that it's just the number of hot dogs. It's not the price, it's not the money you made off of it, it's just the exact number. And your Y is going to be the number of sodas sold. Number of sodas sold. And I picked those variables by seeing what it wanted me to find. It asks in the last line there how many hot dogs were sold and how many sodas were sold. So we know that it doesn't give us that in problem, and we're going to have to find it using what we know about systems. So now we get into actually solving it. So systems, you're always going to see two equations, or at least if it's a normal one. This is a word problem, so you're going to have to make your two equations. So to make your two equations, let's look at what it gives us in the problem, because it's always going to give you exactly what you need. So you need to make sure you're using every single part of what it gives you. So let's start with what it gives us first. Each hot dog costs $1.5. So let's make an equation with the prices. So if we know the number of hot dogs sold is our X, then we can say 1.5 times X. That's going to be the total price of the hot dogs, because we're doing the dollars times X. So like if it was, say we sold 2 hot dogs, which I think we sold more than 2, but say we sold 2, it would be 2 times 1.5, which is 3. We would have made $3. So it works with however many hot dogs we ended up selling. And the same can go with the number of sodas sold. It's 50 cents or $0.5 per soda, so I'm just going to say 0.5y. And the reason I'm adding those together is because it also gives us the total price. At the end of the night, we made $78.50. So 78.50 or 78.5 is our total price. So that equation shows the money. 1.5 times x plus 0.5y, that's the total price of what we made, selling the hot dogs and selling the sodas. So we've got one of our equations, but don't forget we need two. We need two total equations in the end. So let's look at what else it gives us. After it tells us about the prices, it says that we sold a total of 87 hot dogs and sodas combined. So this is, in my opinion, the easier equation to write, because you don't have to worry about coefficients, the money. Now it's just telling us how many sodas and hot dogs we sold. So all you got to do is just say X, which is the number of hot dogs sold, plus Y, number of sodas sold, equals 87, because that's the total number of stuff that we sold. So those are our two equations, and the word problems that you'll see are probably going to be almost completely similar to this one, but just in different examples. So you're usually going to have a price and a total, and you're going to need to write it out like that, and just make sure it makes sense in your head. Like number of hot dogs sold and number of sodas sold, oh, when you add them together, you get 87 because that's the total number that it gives us. And same deal for the price. So now that we have our two equations, we can move on to using math to see what works for x and y. So the thing about systems is it's just like a regular equation, but it's more complicated. When you have a regular equation and you're just trying to find x or just trying to find y, you see what works with the number x, what possible stuff could we put in for x to get it equal on both sides? And this time we just have two equations, so it's more complicated. But I'm going to show you my favorite way to solve systems, and I use it almost every time. It's called substitution. So here's what I usually do as my method. I take the easier equation, which is going to be x plus y equals 87, and I simplify it because we want to have one variable on one side. So we got x plus y equals 87. What I'm going to do is I'm going to subtract x from both sides to get, I'm going to erase that, but to get y equals negative x plus 87. So I just subtracted x from both sides because what you want to do is get a number or a variable, either x or y alone on the side. So that's the first step of substitution. You're getting it alone, getting one of the variables alone. And I could have done this for x too. I just randomly chose y. It would have worked either way, but you want to get it alone. The reason you want to get it alone is because now we know that y is equal to that, to negative x plus 87. Y is equal to negative x plus 87. Since we know that, we can go to our other equation and plug that in for y. So I'm going to say 1.5x plus 0.5 times, well, it's 0.5 times y, right? But we also know that y is the same exact thing as negative x plus 87, because that's what we said up there. We said they're the exact same. So we can just substitute that in, negative x plus 87. And that's all you have to do for substitution, subbing that in. That's the first step of it, really. And you just finish writing that equation. And then now, since we don't have two variables, see in these up here, we had x and y in those two equations. And you can't solve an equation like that if you just have x and y. You have to have just x or just y. So now, since we've replaced y, we have just x, so we can go through and solve it. So if we're just simplifying it, we've got 1.5x. So this is just distribution here. You need to remember, if you've got parentheses, you have to give it to every single one in the parentheses. If you're multiplying it by each thing in parentheses, you got to distribute it out. So 0.5 times negative x, that's going to be minus 0.5x. And then 0.5 times 87, that's going to be 43.5, because that is half of 87. And then we've still got it equal to 78.5. So we can continue solving this by just doing 1.5x minus 0.5x, and the 0.5's just get rid of each other, so it's just x. So you're just taking off half from that. And then I'm just going to consolidate the steps a little bit here. We're also doing minus 43.5 on both sides. And when you do 78.5 minus 43.5, we get that x is equal to, that looks like it's going to be about 35. So I just subtracted that, and that means that x is 35. So if we go back up and remember what x is, up here, x is going to be our number of hot dogs sold. So that's one of our answers. It asks how many hot dogs were sold and how many sodas were sold. So we know now 35 hot dogs were sold, but we still have to answer the other side of it. How many sodas were sold? So since we know up here that our total is 87, x plus y is 87, number of hot dogs and number of sodas totals to 87, we can just say, well, we've got 35 hot dogs and we've got our y number of sodas, and it totaled to 87 total stuff. So to solve that, you just do minus 35 on both sides, minus 35, and then we can get our final solution, which is that y is 87 minus 35, which is 52. So our final answer of how many hot dogs were sold and how many sodas were sold is 35 hot dogs and 52 sodas. And that works for both of our equations that we wrote at the start. So that's the final answer, and we're all good. So I hope you learned a little about systems word problems and substitution. That'll be all for this video. I'll see you next time.